Section 2.1 Interactive Assignment Objective 1. A phlebotomist draws the blood of a random sample of 50 patients and determines their blood types as shown. Here's the blood types. And so what we want to do is we want to be able to construct a relative frequency distribution. So let's go ahead and do that. So recall that the definition of a relative frequency distribution lists the proportion of occurrences of each category of data. So in this case, we want the relative frequency. In order to get the relative frequency, we need to create another table that is the frequency. So creating our frequency distribution, we need to tally up the blood type for each one. So let's go ahead and do that. So for blood type A, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So therefore we have 19 for blood type A. Okay, for blood type B, or AB, excuse me, we have 1, 2, 3, 4. Okay, and then for blood type B, we have 1, 2, 3, 4, 5, 6. So we have 6. And then for blood type O, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so now what we need to do is we need to find out what is the total. Well, we know that the total is 50 up here. So let's just verify that with our calculator, okay, by adding up the frequencies. So let's go ahead and add up the total frequency. Okay, so we're going to add up 19 plus 4 plus 6 plus 21, and that gives us a total of 50. So we know that we have a total of 50. Okay. Okay, now in order to find the relative frequency, we have to find the proportion, meaning the proportion of the blood type to the total. So therefore, we're going to take the blood type and then we're going to divide that. So we're basically taking the blood type frequency and then we're dividing it by the total. So in our first one, blood type A, we're going to take 19 and then divide it by 50. Okay, so if we did on our calculator, 19 divided by 50 gives us 0.38. So therefore, there is 0.38. Okay, and then for blood type AB, we have 4 of them, and we're going to divide that by 50. So let's go ahead and do that. So we have 4, and we're going to divide that by 50, and that gives us 0.08. So therefore, we have 0.08. Okay, and then for blood type B, we're going to take 6, and then we're going to divide that by 50. So 6 divided by 50 gives us 0.12. Okay, and then the last one, blood type O, has 21 of the frequency. We're going to divide that by 50. So 21 divided by 50 gives us 0.42. Okay, now remember that when it comes to the relative frequency, when we add this up, we should either get 1 or close to 1. So let's go ahead and add up our relative frequency. So we have 0.38 plus 0.08 plus 0.12 plus 0.42. And that gives us a total of 1.00. Okay, so that just verifies that. So let's go ahead and put our results into our question. So we have 0.38, 0.08, and then 0.12 and 0.42. So 0.12 and 0.42. Okay, so I think I want to make sure these spaces are nice and clean here so we don't have anything else that's remaining. make sure it's on this side. I'm going to check our answer, and then there's our result. Okay, now it says, according to the data, which blood type is the most common? Okay, so you want to determine the blood type that has the highest number of occurrences. So which one has the highest number of occurrences, which is 21. So therefore, we're going to see that blood type O is, so according to data, which blood type is the most common? So according to our blood type, we know that blood type O is the answer for part B. Now part C, it says, according to the data, which blood type is the least common? So remember, you want to determine the blood type that has the least number of occurrences. We can see here the least number of occurrences is 4, and that represents the blood type AB. So we're going to put in capital A, capital B, so blood type AB is that result. Okay. Now it says, use the result of the sample to conjecture the percentage of the population that has type O blood. Is this an example of descriptive or inferential statistics? And then we're going to select the correct choice below and fill in the answer box to complete your choice. So again, we're looking at blood type O, so let's take a look at that. So blood type O has a decimal of 0.42. So if we take 0.42 and we want to convert that to a percentage, we're going to multiply that by 100%, which means we move the decimal place over to the right twice, which then gives us 42%. Okay, now also let's talk about, recall that descriptive statistics consist of organizing and summarizing data. Inferential statistics uses methods that take a result from a sample, extend it to the population, and measure the reliability of the result. This is an example of inferential statistics since it is extending the sample result to the population. So therefore, we're going to say B, and that's at 42%, and there is our answer. Okay, the last question says, contact a local hospital and ask them the percentage of the population that is blood type O, and why might the results differ? Okay, well, first and foremost, let's go ahead and go down here a little further here. So, recall that a level of confidence is always included with results from inferential statistics, and use this to determine why the results might differ. The results might differ because the results from a study are not likely to be similar to actual patients. Well, that doesn't give us a good solid answer. The results might differ because there is always a chance that the sample surveyed is unlike the population. Well, that's true because you can take a sample from different hospitals and it's not going to represent that population. Part C, the results might differ because the hospital patients are constantly being admitted and discharged. That would not be a sufficient answer. And the results might differ because certain hospitals only treat patients if they have blood type O. No. So therefore, we're going to say that the result is B. So looking at our answer, we'll say that the answer is